parallel serial output. That is parallel input and serial output. Let's look into the definition. The definition says that the shift register which allows the parallel input and produces the serial output. That is, the data is being given separately to the flip-flop in a simultaneous manner. Let's look into the construction. If you see the construction, it is quite simple, wherein you are going to have 4 flip-flops here, as it is said in the definition. Data is given separately to each flip-flop, separate flip-flop. So we have 4 flip-flops placed over here, which is connected to the clock pulse. If you look in on the top of the construction, you can see the control lines where one line is being inverted, another line is not being inverted. That is being connected to the combinational circuit. Yeah, we are done with the flip-flops and the clock pulse and the control lines. Now let's see how exactly the data bits is being given. So here if you see, B0, B1, B2, B3 is the data which is being given in a parallel format, and here you can see Q3 is the serial out. That is, data is fetched in the serial format. If you take a closer look, D0, D1, D2, D3 is the input and Q0, Q1, Q2, Q3 is the output. Let's see how exactly the construction is being done. The control line, the first bit is being directly given without any combinational circuit placed. So later, the output of the first flip-flop falls as an input to the second flip-flop. Reason you are having the combinational circuit. So you have 6 AND gates and 3 OR gates. These are the AND gates which is being numbered 1, 2, 3, 4, 5, 6. And you have OR gates, that is 1, 2 and 3. So the output of the first flip-flop falls as an input to the second flip-flop. And you can see here the connection is being given to the first AND gate. So AND gate has 2 inputs. One input is from the first flip-flop and then the second input is from the control line, which is not being inverted. And if you consider the second AND gate, you can see the control line which is being inverted is being connected to this AND gate, and the second bit which we are going to insert is being connected. So 2 AND gates is being given with the input, and the output of the AND gate is being connected to the input of the OR gate. So the OR gate output is being connected to the second flip-flop, which applies the same to the following one. Consider some random value. So the value I'm considering is 1001. Okay. So I'm considering the value called 1001. Here if you notice, data bit is being given in the parallel format. So here I'm giving the value as 1, 0, 0, 1. So this data bit in the place of B0, B1, B2, B3, I am placing the value called 1, 0, 0, 1. Now, the circuit to work, I have to give a value in a control line. Control line works on the high and the low value, that is 0 and 1. So high is 1 and low is 0. When we give 0, it is load mode. And when we give 1, it is the shift mode. So load mode and shift mode. Initially it gets loaded, later it gets shifted. Before we proceed with that, I wanted you all to look into the tables, that is NOT gate, OR gate and AND gate. If you are very familiar with this gate, the working condition will be quite easy for you to understand. Okay, let's proceed with the things. So now, I'm giving the input here as 0. I'm giving the input here as 0. Let me invert the values. So this particular line is being connected over here. So what exactly happens? Inverted value of 0 will be 1. 1 and 1. So when you come to the downer part, it will be 0 without inverting, 0. Without inverting, the value is 0. Okay. Now, in the load mode. Now it is in the load mode as it is 0. When I give the value, it is directly loaded up over here. So the first flip-flop value is 1. So as you know, there is no any input given here. Only if we go to the shift mode, the value will get shifted up. So nothing is going to happen here as we are working on only the load. So there is no any value, we can consider it as 0 here. There is no any value. So 0 and 0 0 itself, 0 in AND gate is 0. So 1 and 0 is 0. 0 and 0 OR gate 0 itself. So the value is 0. So as I told you, there is no any value given here. So null value, let me consider null as 0. 0 and 0, again it is a 0. And 1 and 0, right? It is being inverted. 0 is being inverted. 1 and 0, it is 0 itself. 0 and 0 in OR gate, 0. So here again it is 0. So no value is being carried out from Q2. Let's consider it as null. Let's consider it as null. And 0 and 0, 0 itself. 1 and 1 in AND gate, it is 1. So 0 and 1 in OR gate, it is 1. So here the value is 1. So whatever the value which I consider, that is 1001, is being loaded up. So shift mode. When I give the value here as 1, I'll just change it to 1. When I give it as 1, here after inverting, it will turn as 0, 0, and then 0. But for inverting, the value is 1. The same value is carried out here. 1, 1, and 1. So now let's see how exactly it works. Okay. So as you give a clock pulse, when the clock pulse is given to the flip-flop, so what exactly happens? This one moves in from this location, that is Q0 is equals to 1. So the value here is 1. So 1 and 1, it is 1. 0 and 0 in AND gate, it is 0. 1 and 0 in OR gate, it is 1. So here the Q1 value turns into 0 and here 1 has been shifted. So as you give a clock pulse, this is what exactly happens in a fraction of a second. So this Q1 value moves in here, this value. So 0, first one connection it is 0, another connection it is 1. 0 and 1. What is 0 and 1 in AND gate? It is 0 and 1, it is 0 itself. 0 and 0, it is 0. And then 0 and 0, 0. So then Q2 value moves as 0 and the loaded OR value is being written here. Now again, 0, 0 and 1, it is 0. 0 and 1, it is 0. 0, 0, 0. Okay. So this turns into 0. Q3 value is 1. So as you give a clock pulse, this is how exactly it moves. So you can see here 1, 0, 0, 1, and the output, if you consider, it is being shifted from the first flip-flop to the second flip-flop 1, and then 0 is being shifted to third flip-flop 0, and then again it is being shifted to the fourth flip-flop 0, and 1 is given out. So this is how serial and parallel works.